So topic 10, which is about the metal and extraction. The first part, we discussed the properties of the metal. The second part, we discussed the reactions of the metal with acid, with air, with water and steam. The third part is about the thermal decomposition. What is the concept of a thermal decomposition? If by the action of the heat, if you can carry out a chemical change, we call this reaction as a thermal decomposition. And how to identify whether a reaction is a thermal decomposition? Whenever the reaction is thermal decomposition, there is always one reactant and there will be more product. So whenever there is a thermal decomposition, there is always a one reactant and there will be many products. And thermal decomposition is always endothermic because by the action of the heat, by the help of the heat, you carry out the change. So it is always an endothermic reaction. So if I say like, and how to identify, this is a very simple thing. You will always have one reactant and many product. Like I have calcium carbonate, I supply heat energy, it forms calcium oxide plus carbon dioxide. So what is this reaction? Thermal decomposition. How I identify it's the thermal decomposition? Because you can see only one reactant and there are many products. Same thing if I say I have calcium nitrate. So I have calcium nitrate. We supply heat energy, it forms calcium oxide plus nitrogen dioxide plus oxygen. So what is this reaction? That is also thermal decomposition. How? Because there is only one reactant and you have many products. So whenever one reactant produces many products, that type of reaction is refers to thermal decomposition, and it is always an endothermic because you have to supply energy or heat energy is taken in when you carry out this change. And when you draw the energy profile diagram, the energy of the particle, this is not about the bond energy. In the reactant will have low energy, the particle, and the product will have high energy. So endothermic reactions, always the energy of the reactant will be lower and energy of the product will be higher. And the minimum possible energy at which this reaction start, we call that as activation energy. So the thermal decomposition of nitrates, carbonates, hydroxides, what will be the product? Again, you have to learn. Example, if you have nitrate, you have metal nitrate. Like example, you have potassium nitrate, you have sodium nitrate, calcium nitrate, magnesium nitrate, and you're supplying the heat energy. So what will be the product if you have potassium nitrate? Or so it is according to the reactivity series. So if you have potassium nitrate, what will be the result? If you have a metal nitrate such as potassium or sodium, it will produce metal nitrite. On heating, metal nitrite plus oxygen. So if we have potassium nitrate, like example KNO3, when we supply the heat energy, it will produce potassium nitrite. Nitrite means NO2. So it will produce KNO2 plus oxygen, which is O2. Then we have to balance the equation. How to balance the equation? This is the product. But how to balance equation? 3 oxygen are there on the left. So we cannot have 3 oxygen on the right hand side. There are 4. So if I put 2 here, it makes 6 oxygen on the left. So I need 6 oxygen on the right. So I put 2 here. So oxygen is balanced because 2 multiplied by 2, 4 plus 2, 6. So 6 oxygen on the right, 6 oxygen on the left. Nitrogen is 2, that is balanced. Potassium is also 2, that is also balanced. So whenever you heat potassium nitrate, you should be able to write the product in terms of symbolic equation as well as the word equation. So sodium and potassium nitrate, when we decompose them or when we supply heat energy, as a result, it will produce sodium oxide plus sodium nitrite plus oxygen. If potassium nitrate is heated, it will give potassium nitrite plus oxygen. So same way, if we have sodium nitrate, you can see NaNO3. When we supply heat energy, it gives sodium oxide plus oxygen. Then to balance the equation, this 2 is put to balance the equation. What about calcium till copper? Like example, if we have calcium oxide, calcium nitrate, magnesium nitrate, aluminum nitrate, zinc nitrate. So what will be the product? So example, if we have calcium nitrate, so as a result, it will produce metal oxide plus nitrogen dioxide plus oxygen. And this nitrogen dioxide, whenever nitrogen dioxide is there, what we will observe? We'll observe a brown gas. So this is always a brown gas. So if you have metal nitrate such as calcium nitrate, the formula for calcium nitrate, the formula should be correct because calcium belongs to group 2, so it should be plus 2. And nitrate, NO3, it is minus 1. So we cross multiply. So the formula for calcium nitrate will be CaNO3 in a bracket 2. That's calcium nitrate. So when we supply heat energy, calcium nitrate decomposes. What it form? It will form calcium oxide. Because when metal nitrate from calcium till copper is heated, it will form metal oxide. So metal oxide means we'll get calcium oxide. That's good. Then nitrogen dioxide. What is the formula for nitrogen dioxide? It is NO2, which is a brown gas, and plus oxygen will be there. So metal oxide plus nitrogen dioxide plus oxygen, and this metal oxide, it is brown in color. Now to balance the equation, how to balance the equation? Whenever you try to balance the equation, always start with oxygen. So 3 multiplied by 2, 6 oxygen on the left, and you have 2 plus 2, 4 and 5. So if I put 2 here, the oxygen will be balanced. So now oxygen is balanced. What about other element? Example, I want to balance calcium. So calcium is 2. I put 2. Calcium is also balanced. Then I try to balance nitrogen. So how many nitrogen are there? This is 2 multiplied by 2. So 4 nitrogen. So I put 4. So nitrogen is also balanced. So now this equation is balanced in terms of oxygen, nitrogen, as well as calcium. So whenever you will heat a metal oxide from calcium, whenever you try to write an equation for thermal decomposition of metal nitrate from calcium till copper, it will always decompose in the same manner. So same way, if we are decomposing aluminium, so aluminum nitrate will be Al in a bracket NO3 and then 3. Why? Because aluminum is group 3, so it is plus 3, and nitrate is minus 1, so aluminum nitride is AlNO3 in a bracket 3. So when we supply heat energy, the thermal decomposition of this result in a formation of aluminum oxide. What will the formula of aluminum oxide? Al2O3, because aluminum is group 3 and oxygen is group 6, so plus 3. Aluminum is plus 3 and oxygen is minus 2, so aluminum oxide, metal oxide, plus nitrogen dioxide, it is on NO2 plus oxygen will be there. So the product is same, only the formula of the product depends on the metal, the valency or the charge of the metal, but the product is always a metal oxide plus nitrogen dioxide plus oxygen. The second part is a balancing. So if you want to balance this, so we have 3 multiplied by 3, 9 oxygen. So first, because it is Al2, so if I put 2 here, so aluminum is balanced. Left hand side 2 aluminum, right hand side 2 aluminum is balanced. What about nitrogen? When we put 2 here, because and this is 3 multiplied by 2, 6, because this is 3 and multiply by 2, 6. So if we put 6, then it means nitrogen is balanced. What about oxygen? 3 multiplied by 3, 9, and multiply by 2, 18. So we have 6 multiplied by 2, 12, plus 3. So 12 plus 3, that is 15, 16, 17. So it means when we put 2, it is not balanced. Now we have to change, we have to check with another number. So if I put 2 here, so 2 multiplied by 2, 4 aluminum. So I should put 4 for aluminum. So aluminum is balanced. Then we'll check nitrogen. This is 3 multiplied by 4. So 3 multiplied by 4, 12. Because it is NO3. So this is 3 nitrogen multiplied by 4. So 3 multiplied by 4, that will make 12. So we need 12 nitrogen. If I put 12 here, so nitrogen will be balanced. But what about oxygen? 3 multiplied by 3, 9 multiplied by 4, 36. So we need 36 here. 2 multiplied by 3, 6 oxygen, and 12 multiplied by 2, 24 plus 6. So that is 30. So we need only 6 to make 36. So we put 3 here. So it will make 36 oxygen. So this equation is balanced in terms of nitrogen, aluminum, and oxygen. So first thing, you should be able to complete the equation, and second one is to balance. So when we will heat potassium or sodium nitrate, it will give potassium nitrite plus oxygen. Sodium nitrate gives sodium nitrite plus oxygen. But when from calcium till copper, when we heat these nitrate, it will give calcium oxide plus nitrogen dioxide plus oxygen. And silver and gold, when we heat these oxides or these nitrates, as a result, what it produces a metal plus nitrogen dioxide plus oxygen. So metal plus nitrogen dioxide plus oxygen will be the product. So as you can see, if silver is heated, as a result, what it will form? It will form silver metal plus nitrogen dioxide. The brown gas will be there, and the oxygen. So AgNO3, silver nitrate is heated. It will give silver metal plus nitrogen dioxide plus oxygen. Then balance. We put 2 to balance. We can start with oxygen, then nitrogen, and then other element, or other way around. It's up to you, any order you can follow. So metal plus nitrogen dioxide plus oxygen, metal oxide plus nitrogen dioxide plus oxygen, and metal nitrate plus oxygen. So potassium and sodium decompose in a different manner. From calcium till copper decompose in a different manner, and silver decompose in a different manner. So you have to learn this thermal decomposition of metal nitrate. Is it clear, this part? Any doubt? So if we have metal carbonate or metal hydroxide, so they have the same trend. Sodium and potassium, they are stable to heat. What does it mean? By the help of heat, you cannot make a chemical change. Like potassium carbonate, if we have potassium carbonate or we have sodium carbonate, when we supply heat energy, the solid, the carbonate can melt, but it cannot chemically, it does not change. There can be a physical change, but chemically there is no change. Same thing, if you have hydroxide, potassium hydroxide or sodium hydroxide, they won't change. Like if I have potassium hydroxide, I supply heat energy, there will be no change. I have sodium carbonate, I supply heat energy, there will be no change. Sodium hydroxide, when I supply heat energy, there will be no change. Because they're stable to heat, that's why we say no change. But when we heat the metal carbonate or metal hydroxide from calcium, again the same trend, from calcium till copper. When we heat them, if it is a carbonate, it will give metal oxide plus carbon dioxide, but if it is a hydroxide, it will give metal oxide plus water. So if I say I have calcium carbonate, CaCO3. So calcium carbonate, when we supply heat energy, it will produce calcium oxide plus carbon dioxide. But if we have calcium hydroxide, when we supply heat energy, it will produce calcium oxide plus water or steam. So metal oxide is common. If it is a carbonate, carbon dioxide. If it is hydroxide, then it will be water. And this happened for all of them. Like if I heat zinc carbonate, it will give zinc oxide plus carbon dioxide. If I heat lead carbonate, it will give lead oxide plus carbon dioxide. And for silver carbonate, when we supply heat energy, it will give metal plus carbon dioxide plus oxygen. Whereas their hydroxide does not exist because these are not stable compound or does not form a stable compound. So they are not existing. This compound does not exist. So this is a table which you have to learn regarding the thermal decomposition of nitrates, carbonates, and hydroxide. So it is according to the reactivity. It's easy to memorize in terms of reactivity and work out the product for the thermal decomposition. This table is just information. I don't want you to memorize because it's not that easy. This is just information just to identify different types of compounds are there. Look, whenever you have group 1, 2, 3, they're all compounds are what? They're white. So you can see all of them are white. But when you have transition element, when they form a compound, their compounds are colored. Example, when you see copper nitrate. So copper here and nitrate. What is the color? Blue in color. Copper chloride, blue in color. Copper bromide, black in color. So all the transition element here are forming a colored compound. Other than transition, all are forming a white solid. So in the question, solid copper carbonate undergo a thermal decomposition. So copper carbonate undergo a thermal decomposition. So we have copper carbonate. Copper carbonate means it will decompose into what? It will decompose into metal oxide plus carbon dioxide. So when copper carbonate decompose, what will be the product? The product will be copper oxide, metal oxide plus carbon dioxide. That is a decomposition of copper carbonate. So the question is, state the color start and end. So what will be the color at the start? First we have copper carbonate. So what is the color of copper carbonate? Using this table, what is the color of copper carbonate? So the copper carbonate will be green in color. Then what is the, it formed copper oxide. So what is the color of copper oxide? So copper and oxide, oxygen. So copper oxide is black in color. So the question is, what is the color change we observe? What will be the color change? Or starting color will be green and the final color will be black. Then write a chemical equation for thermal decomposition of copper carbonate. So when copper carbonate from calcium till copper, when it decompose, it will give copper oxide, metal oxide plus carbon dioxide. And this equation is already balanced. So we don't have to balance. How do we know the starting color? As they mentioned, we have a solid copper carbonate. So in the beginning, copper carbonate. So when in the beginning copper carbonate is there, when you supply heat energy, it gives copper oxide plus carbon dioxide. So what is the color of copper carbonate? When you check the table, the color of copper carbonate. So copper from here The copper from this side and carbonate, so copper carbonate will be green. And what it form? It form copper oxide, so copper oxide it will be black. So starting color will be green, where the final color will be black. Then this is the equation for decomposition of copper carbonate. Then copper to nitrate decomposes. So whenever metal nitrate is heated, if copper nitrate is heated, what is the product? This is the thermal decomposition. Again, once you memorize the table, it will be very easy to answer this question. So when we heat copper, because it will decompose in this manner. So metal nitrate decompose into metal oxide plus nitrogen dioxide plus oxygen. So copper nitrate will decompose into copper oxide plus nitrogen dioxide plus oxygen, and equation must be balanced. So here 2, 4 and 2 will be there. So metal oxide plus oxygen is given, nitrogen dioxide is given, so we have to add a copper oxide. Then balance the equation, put 2 and put 4, so equation is balanced. Only oxygen gas is collected at X. Why? Look, when you heat copper nitrate turn into copper oxide and it gives two gases, nitrogen dioxide, which is acidic because non-metal oxide are acidic, and oxygen. So acidic oxide, nitrogen dioxide is acidic oxide because a non-metal. And acidic oxide, as we discussed already, it can react with base. So when nitrogen dioxide passes through the sodium hydroxide, sodium hydroxide is a base or alkali. So nitrogen dioxide reacted with the base and only gas which is coming out is oxygen. So what is the reason why the gas collected at X is only oxygen? Because the nitrogen dioxide is acidic oxide which react with base or alkali which is sodium hydroxide. The sodium hydroxide is reacted with acidic oxide, non-metal oxide, and as a result, because two gases were there but only one of the gas is collected, nitrogen dioxide and oxygen, but nitrogen dioxide vanish here, but oxygen continue because oxygen it's not an oxide of any acid, so it continue and we collect the oxygen at point X. So this was about the thermal decomposition. The next session we will do extraction, like how we can obtain these metals from their compounds. So today we started a new topic which is about the metal, chapter 10, and we discussed some properties of the metal and their reaction with acid, alkali and water.